Text classification plays an important role in our everyday lives due to increasing use in areas such as speech recognition, social networking, marketing, and so on. Our project was based on text category analysis, where we created a program that predicts labels for a manually labeled dataset. We used 1,537 documents from the GitHub code review database. Our goal was to use different implementations of machine learning and see how they were applicable to natural language recognition, as well as how various parameters could improve that recognition. To build an optimal classifier model, we used two data splitting methods called Leave One Out cross-validation and Monte Carlo cross-validation. We also used several vectorizers called Count Vectorizer and TF-IDF Vectorizer, and the naive Bayes classifiers from the sklearn library for Python, multinomial NB, complement NB, and Bernoulli NB. We also took use of the linear regression classifier. The main workflow was as follows. First, a vectorizer and a classifier were chosen and parameters were set. Then, the data was split into training and testing sets, which were used for training and testing respectively. This procedure was repeated many times. The next step was to change the vectorizer and/or classifier or reset the parameters. The goal of this procedure was to find an optimal classifier model that would give the best results. We gave special consideration to results obtained by the best models. These results were in the form of confusion matrices, which were then analyzed, and a decision about overfitting was made for each model. Overfitting is a modeling error where a classifier is fit too closely to a limited dataset. A signal to check for overfitting is when the model has a high accuracy for training data, but a significantly lower accuracy for testing data. To prevent overfitting and to increase test prediction accuracy, we tried to find and regroup irrelevant or weak labels. In our study for each category of labels, after finding an optimal classifier, we checked for overfitting, which was confirmed for all three categories of labels. By analyzing confusion matrices, we were able to reduce the complexity of the model by reducing and regrouping certain labels, which in turn increased the test prediction accuracy of the model.